Okay, well, as you can see, I'm here in my kitchen setting the idle air control valve. Never a dull moment with this thing, I tell you. If you saw my previous video, we were talking about doing the seals, and then I came upstairs, I got to do this. So let me show you how I've got it set up. I've got hoses that hooked up to my faucet here, and then it runs water in down here and then out down here into this pot. And then I can use the thermometer to check the exit temperature of the water and also kind of in this area here. And so I've got my little handy dandy adjusting tool here. And I made this little gauge out of a popsicle stick. And you can see that ledge there is 2.5 millimeters. And what that corresponds to, if you, let me switch hands here a little bit. If you put this one part over there on the adjusting screw, and I'll try to get as close as I can, the other ledge will sit kind of on this thing right here. Not this washer affair that goes up and down, but the cone that is actually responsible for blocking the airflow. So it's kind of it gives you a little bit of a gauge, and you see I'm on the back side of that washer. It gives you kind of a little bit of a gauge as to where you are in the big scheme of things. So what you're trying to do is bridge between that little adjusting washer with the two slots in it and the lip of that cone. And you have to spend a little time figuring out how this thing works, but basically the way it works is the part that you see here with the slots is a nut, and you can screw it down. Let me turn off the faucet here so you can see here a little better here, and let me get something maybe to point with here. Get a little toothpick or something out of the kitchen drawer. Oh, here we go. Okay, so I'll get my little pointer here. So this outside cone, this outside adjusting ring, you can thread it all the way down, and then you have a cone in here, which is what's responsible for either opening and allowing airflow to come through or blocking it off. And then you have this kind of pin with a washer, and this when the body here is cold, this pin with the washer contracts and goes down, and it pulls that cone down with it. Let me turn on the water here, and I'll put it over to cold, and you can kind of see as we're talking here. So we got the flow of water, and then I can kind of check my little reservoir down there. So now we've got the temperature declining. We're down to 100 degrees again. So it's kind of hard to see, but what you'll see is as this, let me see if I can put some light on the subject here. As this body out here, as this area here where the water is circulating cools down and starts reducing the temperature here, see we're down to 75 degrees, the pin will go down, and that washer will grab the cone and begin to retract it. And you can see already that if you look down in there, you can see around the cone a passageway has opened up because the cone has gone down below our adjusting ring. Now, turn this off for a second. You kind of have, it's a little bit confusing, and you kind of have to fiddle with it to get the hang of what's going on. But basically, when it's cold, that center pin and washer pull the cone down. And then, depending on where you adjust this ring, dictates whether or not the cone being down opens the passage or not. So in other words, if it's cold and this pin pulls the cone down, but then you thread this outer ring down, you basically are chasing the cone down and you can seal it off. So to completely disable the idle air control valve, you can actually get in here and turn this outside threaded nut with the slots all the way clockwise, tighten it down, and it will push that, it'll close off that passage for good. So if you want to totally disable your idle air control circuit, you just open this up and do that. If you want to adjust it to a specific temperature, which is what I'm in the process of doing, and I mentioned before in my video I had it set to where it opened or where it shut down at about 140 degrees. But the problem I ran into was the water flowing through it, keeping it at 140 degrees with the wind, flow of driving down the highway and stuff, was causing this valve to kind of open and close and let in little amounts of air when I didn't want it. So I decided to dial it down to where it closes at around 100 degrees. Now I had blocked it off by using that little tape method I showed a couple of times, where you just block off the entrance hole to the air on the other side of this thing. But the problem then was I had absolutely no assistance when the motor was cold as far as keeping it idling. So then, for the first 5 minutes, the idle was down at 500 RPMs and it felt like it wanted to stall, at a signal. So that was no good. So I thought, well, what I really want is a setting where in the morning when I first fire up the truck, it'll give me a little assistance for 2 or 3 minutes until things get rolling and the motor starts heating up and all that. But I want it to shut off around 100 degrees when the water temperature gets to about 100 degrees, so that then when the water gets up to, more like 160, 70, if I park the truck for 5, 10, 20 minutes and then come back out from the store and get in and fire back up, my water temperature is still going to be around 80 or 100 degrees, and so I don't suddenly have this thing jumping back in the mix. So I'll just cut to the chase as far as how the setting is. If you dial this thing clockwise, tighten it all the way down, and then back it out 2 3/4 turns. That's where I have mine right now, and that will get you to where it shuts off at right around 100 degrees. And the way you can verify that is with this little guy here, or you can just watch the pin and the cone setup real carefully. So let's do that. I will turn the sink on here, the faucet on, to where it's about going to pump through water at about 100 degrees, plus or minus. And wait till things warm up here a little bit. Okay, so that water's coming out, should be about 100 degrees. Let's double check it here. Yeah, so 103, 102. Okay. So then now if we watch this affair here, you should be able to see that cone start to come up. So it's a little bit difficult to see because it happens so slowly, but the giveaway is this little washer, because when this pin gets above it, you'll start to see a gap form between the top of the cone right there and this washer, and that's the giveaway that this cone has stopped coming up, because what's happened is the cone has hit this over here. Okay, so the cone has hit this and shut it off, and then this thing will continue to come up. So if we change the temperature really hot, you'll see that happen. So now I've got the temperature, up at 150 something degrees. And then if you watch very carefully, you can kind of see there's a gap that will form between, it takes a little minute to happen, but you can kind of see it on camera here. So see that little gap starting to form between that washer on the pin and the cone. See it happening there, just ever so slowly as the water temperature goes up. And the reason that's happening is because the pin is still rising as the water gets hotter, but yet the cone has intersected with that outside ring. See, now you can really see it. So the pin is still traveling up, but the cone has already hit our little adjustment ring and said, okay, well, the cone can't go any further because it shut the airflow off. So see, that's just how you set that thing. Now the other thing to know about this is this little, and we can check the temperature, see where we're at, so 135. The other thing to understand is that this air passage has to be airtight around here because you've got air going from that cone over here. Oh, and by the way, for anyone's curious, I smashed my thumb with a hammer while I was putting my differential in about a month ago, so it's my nail finally growing out there, but just in case anyone was wondering. So, but this chamber has to be airtight, so there's a little gasket that has to be on here, and when I put mine back together, I'm going to put a little bit of RTV sealant around this, just to ensure that no air is creeping in there. And see, if you look now, you can really see how much higher that pin and washer is above the cone. So if you want to make adjustments to specific temperatures, you just monkey around with this, pump water through it, and then you take some measurements and you adjust this little guy in so that basically when the water hits the temperature you're interested in, having this shut down at, that's when you just begin to see that gap forming, and then that'll tell you for sure that, okay, the cone has reached the top of its travel as far as this adjustment ring is concerned. And then, of course, you can just, turn it clockwise to have it shut off at a lower temperature, or you can turn it, counterclockwise to have it shut off at a higher temperature and thus, give you more assistance when you're starting the car in the cold. So if you live in, Montana, you might not want to run 2 3/4 turns. You might want to run 3 or 3 1/4 turns, or even 3 1/2 turns, because you really want, extra air going through the motor to help things get warmed up. So that's kind of, the rundown on how I adjust the idle air control valve and kind of the little apparatus that I use. Shut this off, don't want to waste water. And how this cone assembly functions. And we can kind of, if we suddenly turn cold water on here, we'll see this thing very rapidly. It takes a second to kind of flush the hot water out of my little setup here. Okay, now we're starting to get some cold water. So you can see already, just while I was talking, see that gap is already just about vanished. And you can use your little thermometer. See, we're down to 70 degrees again. So that has started to pull down that cone and then open that little passageway, that air passageway around here. And for anyone who hasn't seen my other videos, of course, that little hole right there is the inlet for the airflow that comes into this little area here and then pops out the back. So, as I've mentioned several times now, if you need to diagnose this without taking it all apart, you can always just put a piece of tape, wrap it over the lip, and block off that inlet hole, and that has the same impact as if you dialed this outer ring all the way down to shut that whole system off. So, okay, well, that's again a little information on Toyota's crazy little temperature controlled idle air control valve, which is responsible for adding a little air when you first turn on your 22RE, and I think they still use similar methods to this. I was working on a buddy's 2006 Tacoma a couple days ago, cleaning the throttle body and cleaning out the mass airflow sensor for him to help his truck run better. He's got 280,000 miles on it. and when I pulled the throttle body off, I think there was a water hose going to it. So Toyota probably uses the same kind of system on their new cars. So, okay, well, as always, feel free to use the comment section below there. If you've enjoyed the video, click like and subscribe. That helps out a bunch. And thanks for watching.